All right, yesterday we stopped here. We talked about finding the slope of a tangent line to a curve, which is finding the slope of the curve at that x value. Now, however, that doesn't take in consideration if, let's see here, if we have a situation like this. Now we can see that we have a tangent line has a slope. This tangent line has a slope, we could compute it. But what happens if x gets incredibly close to this position where this tangent line would be vertical? Well, that means that our limit would not exist. Okay, our slope would be undefined, right? So in that case, what's going to happen is we get this positive or negative infinity for our limits, and then our slope is undefined. Okay, or you can see in this illustration from your book also. So if you run that limit process to find the slope of a tangent line, and you get does not exist, you get positive, negative infinity, that means we have a vertical tangent line. That means the slope is undefined. Okay? Well, now we get to the derivative of a function. We've now arrived at a critical point in the study of calculus. Well, I've told you that there are three major things we're studying this year: limits, derivatives, and antiderivatives. Well, we've studied a lot of limits. Now we're going to start studying derivatives. I hope you're really excited. This is more fun in class. You better be excited. Now finally, we learn about derivatives. That limit that we just learned about yesterday to define the slope of a tangent line is also used to define one of the two fundamental operations of calculus: differentiation, or finding the derivative. If you'll notice, the definition of the derivative of a function is given by this limit that we worked with yesterday. Okay, the derivative of a function f at x, some value x, is given by f prime of x. That means the derivative of f. Limit as delta x goes to 0. F of, instead of c now, we're just going to leave it as x, plus delta x minus f of x all over delta x. Now, of course, this limit has to exist. This f prime is a function of x. Mr. Bonley, is it okay if we stop writing this delta x? Well, yeah, there's another way to write this. We could say the limit as h goes to 0 of f of x plus h minus f of x all over h. That would be fine too. All right, these are different ways of writing the derivative. We learned this one already, f prime of x. This is f prime of x. That means the derivative of f. This is another way to write the derivative. This is dy dx, the derivative of y with respect to x. This is y prime. When we use y prime, when they start out with the function naming it y, this means take the derivative of f. So this means take the derivative. And this is a form we won't use too much. Take the derivative of y with respect to x. So, in general, dy over dx, dy dx, this is a quick, non-formal way of saying the derivative of y with respect to x is equal to that derivative or that limit process which we developed and defined yesterday, and it's equal to f prime. So this is the limit process of finding the derivative. we'll spend a couple chapters learning how to find derivatives quicker. All right, let's find the derivative by the limit process. Find the derivative of f of x when f of x equals x cubed plus 2 times x. Well, we need to start out by saying f prime of x is equal to, that is saying we're finding the derivative. This is the derivative. F prime of x equals, they said limit process, so limit as, I'm going to use delta x this time, and that will be f of x plus delta x minus f of x all over delta x, just like we've done yesterday, except for instead of a number, we have x. All right, limit delta x goes to 0. Evaluate f at x plus delta x, and we get x plus delta x cubed plus 2 times x plus delta x minus f of x minus parentheses x cubed plus 2x all over delta x. Now we need to expand this problem. Expand the numerator so we can combine like terms, hopefully cancel some things, just like we've talked about yesterday. Okay, x plus delta x cubed. Well, that's just x plus delta x times x plus delta x times x plus delta x. You can muscle your way through that, or you can really think about how you guys expanded these back in Algebra 2 or Pre-Calc. For this one, I'm going to use that Pascal's triangle. And we got 1, 1, 2, 1, 1, 3, 3, 1, 1, 3, 4, 6, 4, 1. Now this is a third power, so it means third row. This is row 0, row 1, 2, and here's row 3. Okay. That means that these are the coefficients, 1, 3, 3, 1 are coefficients of the expansion of this polynomial. So we're going to have 1 times x cubed plus 3 times lower the power on x and raise the power on x or delta x. So it'll be power 1 because before is power 0 plus 3x delta x squared plus 1 and then x to the 0 delta x to the third power. Keep going, distribute your 2. Distribute your negative all over delta x. Now if you're still hung up on this binomial expansion using Pascal's triangle, just multiply this out. Alright, combine some like terms. Okay, I have an x cubed here minus x cubed. I got a 2x here minus 2x. And then looks like I can't combine anything else. Alright, factor delta x out of the numerator. That'll be 3x squared plus 3x delta x plus delta x squared plus 2 all over delta x. Looks like delta x is canceled. Divide to 1. And we get limit delta x goes to 0. And then 3x squared, 3x delta x plus delta x squared plus 2 If you let delta x go to 0, that means this term goes to 0, this term goes to 0, and with our direct substitution, we are left with 3x squared plus 2, and that is f prime of x. That is the derivative of the function f. That means along the function f, for any x value, this would be the slope of the tangent line. All you have to do is plug in an x value, and you get your slope of the tangent line, or the slope of the graph at that particular x value. Okay, and technically we didn't have to write f prime here again because we wrote it up here, but it's just kind of nice to at the last step. Now, yesterday we didn't go over writing the equation of the tangent line, so let's use this problem to write the equation of the tangent line. Well, to write the equation of the tangent line, we know we need slope and we need a point. Well, let's use our point-slope form. We need slope. We need slope when x is 1. Well, slope then, for the graph of f, will be the derivative evaluated at 1. That'd be f prime of 1. Evaluate the derivative at 1 and you get 3 times 1 squared plus 2, and you get 5. So the slope of the graph when x is 1 is 5. Now we need our point, our xy coordinate. Well, we know x is 1. Well, how do we get the y value? Well, we evaluate our function at 1. And our function is way up there, x cubed plus 2x. 1 cubed plus 2 times 1. 1 plus 2 is 3. All right, our y is 3. Our x is 1. Our slope is 5. So our equation of the tangent line is y minus 3. 5 times x minus 1. That would be our point-slope form, and you can leave it like that. But you also have to notice that you could add 3 to the other side and get the modified point-slope form. Or you could distribute your 5 through and combine like terms and get the slope-intercept form. But in FRQ or any work, any practice work we do, leaving your equation in point-slope form is definitely good enough. Okay, let's start with the derivative setup. We know f prime x equals the limit. Do you guys want to use delta x or you want to use h?
H.
Okay, we'll use h. Simmer down. H goes to 0. F of x plus h minus f of x all over h. Do you have to write this out every time? Not necessarily, but it's really good practice right now, so you remember it, okay? Evaluate the function x plus h. So we have the limit. H goes to 0. That'd be square root x plus h minus square root x all over h. And I think we know the technique needed to solve this one. What should be what? Conjugate, yeah. Multiply by the conjugate, top and bottom. All right. X plus h plus square root x all over square root x plus h plus square root x. All right, let's see what we get. Okay, remember, this is the distribution problem, right? Square root of x plus delta, or square root of x plus h times square root of x plus h is this x plus h. That'd be a negative, and then a positive, and then a negative, so they cancel. And then minus x all over h times, and we know not to distribute this, right? Square root x plus h plus square root x. Looks like we have x minus x in the top. So we have h over square root x plus h plus square root x. Looks like h is divided to 1. One over square root x plus h plus square root x. It looks like we cancel the h's, right? Now it looks like we can do a direct substitution of 0 for h. And we get 1 over square root x plus square root x, because x plus 0 is just x. And then that gives us 1 over 2 root x. Obviously, we could rationalize this if we wanted to, right? There's not a big need to, I think. Okay, f prime of x equals 1 over 2 square root x. What does that mean? That means the derivative, or the slope of the tangent line, for all tangent lines along the function f can be found by using 1 over 2 square root x. Okay, so we found the derivative, which is f prime. Now we need to find the slopes of the graph, which means find the slopes of the tangent lines. So we need to find f prime of 1 and f prime of 4. Let's do it. F prime of 1 equals 1 over 2 square root 1, which is equal to, if you do not write out f prime of 1 equals and then make a substitution, and you just have 1/2, I have no idea what 1/2 means. When you write it out like this, I know the slope of the tangent line is equal to 1/2. Okay, next thing, f prime of what, 4 or 2? Why 4? There you go, it's the x value. Okay, f prime of 4, 1 over 2 square root 4. Looks like they're being nice to us. All right, 1 over, what would that be? Is that 4 then? Square root of 4 is 2. 2 times 2 is 4. Okay. Bonus. Let's write the equation of a tangent line to the function f at x equals 4. So equation, tangent line at x equals 4. Okay, remember, we need a point, we need slope. What's our point at x equals 4? They gave it to us, didn't they? What's our slope? Which means, what is f prime of 4? That's 1/4. Okay, y minus 2 equals 1/4 x minus 4. Not too bad, is it? All right, so we got the derivative when x equals 1, the derivative when x equals 4, slopes of the tangent lines, we found those, or they could say slopes of the graphs. Now, what's happening at x equals 0? Well, let's find f prime 0. Uh-oh. The derivative is undefined, which means the slope of the tangent line is It's undefined. What kind of vertical tangent line is that? It's a vertical one, right? It's a vertical tangent line, x equals 0. But first, is the point 0, 0 on the graph of f? Yeah, you plug in 0, you get 0, right? So it is a point on the graph, so you better check that, right? Better make sure that point is actually on the graph of f. It is on the graph of f. We plug in 0 into the derivative. The slope of the graph when x equals 0 is undefined, therefore vertical tangent line, right? Was it AL or LE? Okay, vertical tangent line. Last one. Find the derivative with respect to t for the following function. Y equals 2 over t. Now, because they said y, my derivative will be y prime or dy dt. dy dt. The derivative of y with respect to t. Yt, because that's the variable that's on the other side. Okay, I like y prime though. And fun fact, you could say y prime of t, right? Did somebody say that? Did you say that, Megan? Okay, yeah, we could say that also. What's up?
How do you rate
Hmm?
it doesn't use f of x?
What do you mean?
Like, you are supposed to put f of that. You rate the spec y.
Well, it's like y of that then, right? You could say y of, oh, I better not forget something. I don't want to squeeze it in there. H or delta x? Ooh, feeling fancy. Okay, so I'm going to say y of x plus delta x. Ooh. Those are sideways t's. Those are all sideways t's. It's pretty much a progression of the t's waking up in the morning, laying down, getting up, stretching a little bit, and now they're standing up. Delta t. There we go. All right, limit change in t goes to 0. And so that would be what? 2 over t plus delta t minus 2 over t all over delta t. I believe this is a common denominator problem, isn't it?
You use delta x would really matter if it was with t.
Well, here's the deal, guys. And I said kind of like a sideways t. It's a joke, but it's also kind of true that people's handwritings are not going to grade you on spelling, actually, if you use t's or x's, kind of, as long as it makes sense. So I'm not going to mark off for that. I might, however. I reserve that right. All right, this fraction needs t over t, so we have 2t minus this fraction needs t plus delta t. And our common denominator is the product of t times t plus delta t all over delta t. All right, after you find a common denominator, it's going to be expand and combine. That'd be what? Minus 2t minus 2 delta t all over t times t plus delta t. Mr. Bali, you didn't leave enough room because I'm going to use the advanced move and multiply by the reciprocal right away over here. Because I know I've done these problems a couple times, right? Eventually we're doing this, right? Okay, 2t minus 2t. Can we cancel our delta t's now? You okay with that? I think we're kind of iffy still sometimes. Negative 2 delta t. Now we can cancel or divide to 1. I'm running out of room, so I'm just going to arrow up like this. So I have the limit. Delta t goes to 0. Negative 2 over t times t plus delta t. Can I make a direct substitution now? Looks like I can. This goes to 0. And we get negative 2 over t times t, essentially. And then we get negative 2 over t squared. And that is y prime. I'm just going to write this over again. You don't really have to because you started out by saying y prime. It's kind of nice, though, in the end if you do. What's the slope of the tangent line to y when x equals 1? I should say when t equals 1. And negative 2 is plug in 1, right? Okay. Can we find equations of tangent lines for any x value they give us or t value they give us? You bet. Okay. All right, so slopes of the graph at one point is the derivative, and we use the definition of the derivative to find it. Let's see here. Let's go page. I want to make sure I want to use this previous assignment as your current one. Let's go 11 through 31 odd on page 104. Okay, on 25 through 31 odd, it says use your graphing utility to graph the function as tangent line at the point and use the derivative feature of the graphing utility to confirm your results. Only do part A. Part A only means find the equation of the tangent line. We'll work with a calculator later to help you guys find the derivative pretty quickly, like instantaneously almost. We'll do that later though. Okay, got a couple minutes to get started. Might as well do that.